Geometry class. This is going to be great for you. This is stuff that you've talked about before. I'm sure you understand it. We're going to get real definitions. It's going to be so much fun. Here we are. We're going to be talking about parallel lines and transversals, okay? Here's the definition of parallel lines, okay? It's two lines that exist, that lie in the same plane, and they don't intersect, right? We always knew that parallel lines are lines that move in the same direction, but they never intersect. But the cool thing about this definition is that they're on the same plane. Oof, that's horrible underlining. Maybe I'll do it like this. Here's how I'll underline it. They're on the same plane, right? Cool. There it is. They're on the same plane. And they don't intersect. So we'll get rid of this so you can see it. Parallel lines on the same plane, don't intersect. Lines that don't intersect but are not on the same plane. Let's use a different color. That are not on the same plane. Right? Let's go ahead, not on the same plane, and we'll use a different color for this. They're not coplanar. Those are called skew lines. That's this guy right here, skew lines. Oops. Yo. A little arrow. There it is. Skew lines. All right. So, skew lines. Now, we don't have any skew lines here, right? We have a set of parallel lines. But this line here intersects with everything. This is actually called a transversal. A line that cuts through parallel lines on the same plane. That's a transversal. And we're going to talk about transversals later. Not right now. But I want to do a little comparison, right? Let's do parallel v skew. My K's aren't any good on this thing. Anyway, parallel versus skew. What do they have in common? Well, what do they have in common? They don't intersect. Both of them are lines that don't intersect. They don't intersect, right? And then what don't they have in common? What's the difference? What they don't have in common? Oops. Let's just do that. I don't want to take any more time just writing this crap. Okay, parallel lines are planar. They exist on the same plane. Ooh, that's a horrible R. Let's try that again. They are coplanar. Coplanar, right? On the same plane. On the same plane. And I'm going to show you an example of that momentarily. Whereas skew lines, oops, sorry, other color, non-coplanar. That's just the opposite, right? Okay, you ready for fun? Here we go. Let's get onto this. All right, and I'm going to hide this. No, I'll leave it up so you can have your definitions up here. Okay, so this example goes along with this figure, right? And it says, name all planes parallel to A, B, D. Okay, that's the top of this figure here. So it's, oh, I'm not drawing on this. Well, I should be, right? Oh, maybe it's over here. Let's see if I can draw this way. Oh, I was drawing in white. You dingbat. Sorry about that. So if this is ABD, this whole plane here, even though it's labeled with 3 letters, that's my next thing, but here it is. It's this top of this box, this rectangular prism that has another plane cutting through it. ABD is this whole plane up here. And why do they name a plane with 3 letters? Is because if you have a point, if you have 3 points that are non-collinear, 3 non-collinear points, right? They don't exist, they don't all 3 exist on the same line. They form a plane. They exist on the same plane. All right, so that's why we label a plane with 3 points. All right, so this top of the box, right? Now we have to name all the planes that are parallel to ABD. Well, we have the top of the box, so the parallel plane would be the bottom of the box, right? It would be this down here, this EFH plane, or EF. You could even name it EFG, EHG, FHG, FGH. However you want to name it, it's this bottom. So everything that's outlined in red, and I apologize for that horrible, horrible scribbling that I just did. Let me get rid of it now. See how much of it I can actually get rid of. Ooh, I can get rid of all of it. Look at that. All right, now we're going to look at all the segments, the line segments that are parallel to CG. Here's CG over here, right? This is CG. Well, what would be parallel to it? Well, DH is one of those. Everything that's sticking up, right? Parallel, B and F, and A and E. So we don't even have to look over here with the answers that they gave us, right? And then anything that is skew to E and H, I'm going to go back. I'm going to get rid of those 4 lines. Now we're going to look at things that are not on the same plane, right? Skew lines, they don't intersect and they're not on the same plane. So let me outline E and H. E to H, there it is. Okay? I don't like it, but let's try this again. E to H. It's this guy right here. So I am going to look for anything that's not on the same plane, so it doesn't intersect and not on the same plane. So let's talk about this guy up here. D to C, or CD, there it is right there. All of these guys up front, are either on the same plane or they intersect. So this whole front side doesn't work. But what about AB from the top of the box? That works, right? That's one of them. So we have CD and AB. We're looking at skew lines. How about BD? BD doesn't intersect with this bottom line down here, and it's not parallel to it. So if it isn't parallel, right? So what do we have? A, B, B, D. How about this guy way back here? It's pointing in a different direction. It doesn't intersect. It's not on the same plane. It's not parallel. And then I would guess this back corner here that points up and down like that. So B and F, yeah. C and G, yeah. B, D, and A, B. We got them all. All right, so we'll move on. We'll get used to this. You'll try this on your own. And I'll get rid of this guy too. And we're going to move on to the next set of definitions. So we're going to talk about angle relationships. And I think you've already talked about all of these things. And it's going to take a little bit of time. Two parallel lines, two lines in a transversal, right? So this first example, right, are just two lines. They're not parallel, but they are cut by a transversal. So if you have two lines that have one line that intersects both, we're going to have all of these definitions. We're going to have interior angles, right? All the interior, everything that's inside of the two lines, right? So 3, oops, I'm not drawing on this yet. There we go. 3, 4, 5, and 6. They're all interior, right? So interior, we'll call that the red look. Now we'll go to purple, and we'll talk about the alternate interior, right? Alternate interior, well, it's on, you have your transversal here, so you have an interior angle, right? And it matches up across the transversal. So 4 and 6 are alternate interior angles, and 3 and 5 are alternate interior angles. And they go together, so I'm going to connect them with lines, okay? Consecutive interior angles. Well, consecutive interior angles means they're right next to each other inside along the transversal. So I have to use a different color, right? So let's use this blue color. And so 4 connects with 5. These are consecutive, right next to each other, interior angles. Consecutive interior angles. You'll see that there's no such thing as consecutive exterior angles because they can't be right next to each other. They're not next to each other. 1 and 8 aren't next to each other, but they have their own little designations. So let's talk about the exterior angles. Hopefully yellow will show up. I'm going to use yellow for it. Oh, I forgot to label them. Blue. Let me go back and go lilac or purple. There we go. So I am back with yellow. All right. So put yellow dots by all the exterior angles. 1, 2, 7, and 8 in order. And that's super easy. Alternate exterior. Let's just go with plain old black. Alternate exterior would be 1 and across the transversal on the other side of the transversal, but exterior 1 and 7. And then we would also have, oh, should I connect them with the line? Oh, that's messy. Sorry about the mess. 2 and 8. Ugh, I've made a mess. I hope this works out for you. So we went with black. And then corresponding angles, right? Let's just undo all this stuff. You got all this? Corresponding angles means they're right next to each other. So, corresponding angles. So you have the transversal and you have your set of 4 angles, right? And there's another set of 4 angles on the other line down below. Well, what lies in the upper left-hand spot down here? Well, that would be, let me choose a different color. How's green? Let's do green. Green. So this sits in the upper left-hand corner of this set. So 1 corresponds to 5. 2 corresponds to 6. 3 corresponds to 7. And 4 corresponds to 8. Does that make sense? All right. Sorry it's so messy. I'm going to move on. Take that away from you. Actually, let me leave it there. Watch this. Let's try and get rid of all this garbage. Yeah, let's make it clean. Now you know the definitions. Let's do this. Now we have the same idea, right? We have actual parallel lines cut by a couple of transversals. So when you have parallel lines that are cut by transversals, a lot of great things happen. You have these two parallel lines, and the vertical angles will be congruent, the corresponding angles will be congruent, the alternate exterior angles will be congruent, the alternate interior angles will be congruent. It's really, really a lot of super simple ideas, all right? But let's go ahead and see what this example says. Classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding, or consecutive interior angles. So the cool thing is they say, hey, what's the relationship between 10 and 16? Well, they're both exterior and they're across the transversal from each other, so they're alternate exterior angles. And what you're going to learn is that alternate exterior angles are congruent. Huh. Figure. All right. So let's talk about B. Let's see what 4 and 12 have in common. Now these are just corresponding angles, right? They're in the same spot. Right? If I picked up this set and just set it on top here, they'd be in the same position. And these are not congruent, as a matter of fact, because this line cuts at a different angle than this line. If these were parallel, they'd be congruent, but they're not. They're just corresponding angles. Let's go ahead and look at 12 and 13. 12 and 13, oh, I love this one. 12 and 13 are consecutive interior angles, and consecutive interior angles if the two lines that are intersected by that transversal, if those two lines are parallel, if these guys are parallel, this and this, N and L, then they would be supplementary. Oh, there it is. And why? Because, this would correspond up here and they would create that 180 degree angle. But since these corresponding angles, this is parallel lines, these corresponding angles are congruent. Therefore, if this is supplementary, then these two guys inside would be supplementary. Cool, right? It's a lot of information. It's not information that you need on this paper, but I just want you to know it. All right, and last but certainly not least, let's compare 3 to 9. And they're just alternate interior angles. There you go. And that's really it. I just want you to finish this paper and then have a great weekend. I won't see you until Monday. So thanks for your time. If you have any questions, don't ask. No, I'm just kidding. Send me a message. I'll get back to you when I can.